All right, today we're going to look at day 3 of the Polynomial Functions unit, day 4.1. Today we're just going to look at how to find the zeros of a polynomial function. And the zeros, the real zeros are really easy to find because those are where the graph crosses the x-axis. So for this first graph, zoom in here. For this first graph, you see that it crosses at 3 spots. So there are 3 zeros. This graph here, the parabola, it crosses the x-axis at 2 spots. So there are 2 real zeros. This W-shaped graph, it crosses the x-axis at 4 spots. So there are 4 zeros. So really easy to find the number of real zeros from a graph just based off of how many times it crosses the x-axis. All right. Now, when we're going to compare polynomial functions, first let's look at g of x. G of x is shown here in the graph. You see g of x, obviously it has an even degree, and leading coefficient is going to be positive because it's going up as we go towards positive infinity. So even degree, leading coefficient is positive. All right. So as we look at f of x is just a polynomial right now. We're going to have to make a graph ourselves out of that. So in order to do that, we're going to have to just pick some x values and then plug those in. So I'm going to pick from -4 through 3. All right, and then just run those through the function. So I've got a graphing calculator I'm going to use. So -4 raised to the 3rd power plus 2 times -4 squared minus 3 times -4 and let's see what I do here. All right, so that is -20. Then if I run -3 through the function, I get -3 cubed is -27. -3 squared is 9 times 2 is 18. So -27 plus 18 is -9. And then -3 times -3 is +9. So -9 plus +9 is 0. Then we've got -2. -2 cubed is -8. -2 squared is 4. 4 times 2 is 8. So -8, +8, those cancel out. So we're just left with -3 times -2, which is +6. And then if I run -1 through the function, -1 cubed is -1. -1 squared is 1 times 2 is 2. -1 plus 2 is 1. -3 times -1 is +3. So 1 plus 3 is 4. Of course, if I run 0 through the function, I've got 0 cubed is 0, 2 times 0 squared is 0, -3 times 0 is 0, so we're just left with 0, 0, 0. If I run 1 through the function, 1 cubed is 1, 1 squared is 1 times 2 is 2, so 1 plus 2 is 3. -3 times 1 is -3, so -3 and +3, that makes 0. Then if I run 2 through the function, I got 2 cubed is 8. 2 squared is 4 times 2 is 16. Oh, sorry, is 8. So I got 8 plus 8 is 16. Sorry, got ahead of myself there. And -3 times 2 is -6. 16 minus 6 is 10. And then if I run 3 through the function, 3 cubed is 27. 3 squared is 9 times 2 is 18. 27 plus 18 is 45, and then -3 times 3 is -9, so -9 from 45, and you get 36. All right, so we have a good idea of what this polynomial graph is going to look like. So -4, -20 is going to be off of our graph. -3, 0 is going to be right there. -2, 6 is going to be right there. -1, 4 right there. 0, 0, 1, 0, 2, 10. All right, so as we go from left to right, we're going to need to connect these dots, and we're going to connect them with a smooth curve. So no sharp turns, no weird steep changes all of a sudden. So there, and it comes back down through 4. We're going to go through 0, 0, and then come back up through 1, 0 on our way back up to the graph. It looks like that. So that is what the graph of f of x looks like. All right. So now that we have graphed f of x and can compare it to g of x, so if you look at the graphs, you can probably tell just from that how those things are going to shake out. Even if you didn't have a graph, if you had just the polynomials, you should be able to know the end behavior as well. We're going to look at the extrema. Which function has a greater relative maximum? Well, the relative maximum of g of x was between 2 and 3, and the relative maximum of f of x was 6. So f of x has the greater relative maximum. When we look at the key features, we're going to compare the zeros. So g of x had 4 zeros, f of x had 3. F of x's zeros were at -3, 0, and 1. G of x's 0, they're at -1, -1/2, 1, and 2. So that's where all the zeros are there. The y-intercepts. X-intercepts are the same thing as zeros. The y-intercepts for f of x was, of course, at 0, 0. And the g of x y-intercept was at 0, 2. All right, so g of x had a higher y-intercept. Now, the end behavior for f of x. As x goes towards -infinity, f of x goes towards -infinity as well. And as x goes towards positive infinity, f of x goes towards positive infinity. Now, the end behavior for g of x was that as x approaches -infinity, g of x approaches positive infinity, and as x approaches positive infinity, g of x approaches positive infinity as well. All right, so that is how end behavior can be described. We always have these kind of symbols of x going towards positive infinity, x going towards negative infinity, and f of x or g of x or whatever. Y even can be used going towards, and then you'll usually fill in that blank. All right, well, that does it for today's lesson. If you have any questions, be sure to shoot me an email or a Canvas message, and I'll get back to you as soon as I can. Have a great day.